Chapter 3. Okay, in Chapter 3, we're going to think about quantitative demand analysis, and this is the elasticity portion of Chapter 3. In terms of learning objectives, we're going to look at the first four. And learning objective 1 is to apply various elasticities of demand as a quantitative forecasting tool. Okay, so we can use this to evaluate changes in revenues, prices, and/or quantities sold. Second learning objective is to illustrate the relationship between the elasticity of demand and total revenue. Learning objective 3 is to discuss factors that influence whether demand is going to be elastic or inelastic. And then learning objective 4 is to explain the relationship between marginal revenue and the own price elasticity of demand. Okay, in terms of motivation, just think about these questions that might affect, that a business firm might be confronted with. Okay, so if we cut prices by 6%, how many more units will we sell? Notice that this question goes beyond the more abstract theory of demand, where the conclusion is if we cut prices, what happens? And then the answer to that is, well, quantity will go up. But with the concept of elasticity, we are thinking, well, how much will quantities or units we sell go up? Okay, and then once a firm answers this first question, it can go beyond that and think about, do we have sufficient inventories on hand to accommodate this increase in sales? If not, do we have enough workers to increase production? And if sales increase, what will happen to our revenues as a result of the price cut? Okay, and then there's other elasticities that can help us answer questions like how much will our sales change if the price of a related good falls by 4%? And how much will our sales change if household incomes decline by 2%? So these are all important questions that business firms face, and the concept of elasticity can help us answer them. So first, let's just think about elasticity in general, and not just in terms of, not just applied to demand analysis. Okay, so elasticity in general is the measure of the responsiveness of one variable to changes in another variable. Okay, and these can be any two variables. It could be a measure of the responsiveness of crop yield to changes in rainfall. Or it could be a measure of how high a ball bounces when it's dropped from a certain height. And the elasticity concept is usually expressed as the percentage change in one variable that arises due to a given percentage change in another variable. And that looks like this. Okay, so here we have just two generic variables, G and S. Okay, so the elasticity, capital E, between G and S is equal to the percentage change in G divided by the percentage change in S. Okay, if G is a function of S, if G is the dependent variable and S is the independent variable, then the elasticity, thinking in terms of calculus, is equal to the change in G divided by the change in S, and this lowercase d is the notation for a very small change. And from calculus, this is the derivative. Okay, and the derivative is the slope. So the elasticity between G and S is equal to the change in G divided by the change in S times the point at which the relationship is evaluated. Okay, so any pair of S and G combinations could be plugged in to calculate elasticity. And when we think about elasticities, we will consider the sign of the relationship. So whether this number, this calculated number, is positive or negative. If the number is positive, then that means the variables G and S move in the same direction. And if it's negative, that means that the variables G and S move in the opposite direction. Okay, and then the magnitude of the elasticity matters as well. Okay, so if the absolute value of elasticity is greater than 1, then that means the numerator of the elasticity formula is greater than the denominator. So that means that G is highly responsive to changes in S. The percentage change in G is going to be greater than the percentage change in S. Maybe if the elasticity is less than 1, okay, that means G is only slightly responsive to changes in S. Okay, and these should have quotes around them because sometimes the numbers are very similar. 1.01 is not that much different than 0.98. So these terms are relative. Okay, but when G is slightly responsive, that means the percentage change in G is less than the percentage change in S.